demultiplexer and how to implement different Boolean functions with the use of multiplexer, as well as how to implement higher order multiplexer with the use of lower order multiplexer. Like higher order multiplexers are like 8 to 1 or 16 to 1. So if we don't have basic logic gates, and we have a lower order multiplexers, so we have some provision by some ways we can implement that higher order multiplex mux with the use of lower order mux, as well as we can also implement the Boolean, any kind of Boolean expression with the use of mux, different types of mux. So we'll see what is the first. We'll see what is demultiplexer. So everyone is you know that what is the multiplexer. Multiplexer is many to one. It is also called as the data selector. So if we have multiple number of input data, so among those data, multiplexers select one data and transmit through if we have only a single line or single channel, and multiple number of sources are there, so to pass certain data through that single line, we use a multiplexer. Okay, so if we are use at the transmitter side, if we are using multiplexer, so there is also necessity that we perform the opposite function too. So to perform the opposite function of the multiplexing, we use a demultiplexer, which is just opposite of the multiplexer. So it is also called as the data splitter or many to one, one to many splitter. So suppose we have if the data is transmitted from the single source, and so we want that data to be transmitted toward certain destination, because the data is intended for some particular devices. So we have here, suppose this is a computer system, it is a single source, so it will give instruction to many devices. Many devices will be connected through that with that computer. So we'll use one demultiplexer, that is the selector, or also the splitter, data splitter. It direct that particular data to its intended destination. Okay, so this is also called as the data splitter. So okay, so the symbolic representation is like this here. So it indicates, we represent a demultiplexer like this. This just symbol is also the opposite of the multiplexer. So we represent mux using this. So wider side indicates that the more number of lines are here, and narrower side indicates that less number of lines are there. So like this, here the symbolic representation is for the demultiplexer is like this one. Okay, just opposite of the multiplexer. And here this is just example of 4x1 mux, 4x1 demux here. So if we talk about the 1x4, okay, 1x4, it will not 4x only, it will be the mux. So for 1x4 is the demux. This is the simple example. If this is also called as a 1 cross 2 to the power and demux. Okay, so here n is equal to 2, so it will be 1 to 4 demux. Okay, so one is the data line. There will be certain selection lines. So here in this case, n is equal to 2. So the number of selection lines are 2, and the output line will be 4. Okay, so we'll see how to implement, with the use of the various gates, how to implement the demultiplexer. So we'll take the simple example of multiplexer, demultiplexer, which is 1 to 4. Okay, so for that, what is the task? Whenever we want to implement, we know that basic fundamental is that we try to find out the Boolean expression. So now here again we don't have any kind of Boolean expression. So what we will do, we will try to find out, is there any logic by which with the use of that logic we can implement a truth table. Okay, so we know that what is the process for the implementation of any of the task. So what we try to find out, find out that, is there any kind of Boolean expression? If there is any kind of Boolean expression present, what we have to do, we just need to implement with the use of the various kind of gates. But here we don't have any kind of Boolean expression. So what we will try to do, we'll try to find out that, is there any logic by which we can design any truth table, and on the basis of that truth table, we will try to find out the Boolean expression. Okay, so next we'll see how to implement how to design the truth table for demultiplexer. Okay, the concept we will use the basic concept. What is the task? Okay, so the task is here, one is input. Okay, we take some input, is suppose any of the input, x, d, anything. This is the input. Okay, what we want, this input will go to any of this 4 selection lines. So here we are talking about 1 to 4 demux. That means 1 to 2 to the power 2. It means 4 are the number of 4 number of output lines, and 2 number of selection line. Okay, 2 number of selection lines. So we know that this is the first, we need to find out how many number of output lines are there and how many number of selection lines. So for this particular example, 1 to 4 demultiplexer, we know that 4 number of output lines are there. So now assume that those output lines are D0, D1, D2 and D3. Okay, and assume that the input is x. X is x. This x could be anything. So what we want, this x will go towards D0, D1, D2 or D3. Since x is input, it can come from any of the input site. Okay, so only one, this is the one single line which is the output of the multiplexer. So the input of the multiplexer are various sources. So from various sources, according to the combinations of the selection line, one output line be selected from the multiplexer. So according to the combination, that one output line from the multiplexer which will be the input of the demultiplexer should be directed towards the particular output line. Okay, so what we need to do, see, this is the x. So we have to find out for what combination this will go towards, for which this input will go to which output line, for what combination we need to find out. Okay, so we have 2 selection line. So those 2 selection line will have 4 combinations. So 0, 0, 0, 1, 1, 0 and 1, 1. Okay, so now we have to find out the truth table. So for this we will see that if the combination is 0, 0, out this input line X will go to D0 and remaining line will be 0. Okay, 0, 0, 0. Again for the next combination, we'll see for 0, 1, it will, this X will go towards D1 and other lines will be 0. For the next combination 1, 0, it will, this X will go towards D2 and other lines will be 0 and so on. For the last combination, it will go towards D3 and the remaining line should be 0. Okay, so this is the truth table. So on the basis of this truth table, we'll try to find out what will be the Boolean expression for the D0, because D0, D1, D2, D3 are the 4 output lines. So for these output lines, we will try to find out the expression. So for D0, what will be the expression? It will be B dash A dash X. Okay. For D1, what will be the expression? Dash A X. X in this indicates that for this combination it is true. Okay. So for D2, this is D1. For D2, it will be B A dash X. And for D3, it will be A B X. Okay, so we have found out the expression, Boolean expression for the output line, because here 4 outputs are here. 4 output lines are in this multiplexer. So we have to find out the expression for those 4 output lines. Okay, so we know that now. D0, D1, D2, D3. So now we will use various kinds of gates. So okay, we know that here for the D0 we need the ending of B dash, A dash and X. Okay, so for D0 we require one AND gate. For D1 we require one AND gate. For D2 we require one AND gate, and for D3 we require one AND gate. And for to generate here combination of A and B, here we are using, so we require two AND gate for to generate the complement of those selection lines A and B. So now the implemented this demultiplexer is this one, 1 cross 4. Demultiplexer is like this. This is the this is the X. Okay, for D0 it is A dash. So this is A dash B dash X. So it will generate A dash B dash X. For the next, what will be what is the for D1? It is B dash A X. Okay, so here B dash A and X. So it is B dash A X. For D2, it is B A dash X. So here B is going inside A dash and X. B A dash X. And for D3, it is A B or B A X. Okay, so this is a simple implementation of demultiplexer 1 cross 4 demultiplexer with the use of basic gates. Can you try to find out the truth table of 1 to 8 demux? Can you do? No? Okay. So again we'll see. Next for one to eight demultiplexer, what we have to do again? We need to find out the how many of selection lines we need here. So if we observe the demultiplexer task, it is generating 8 number of outputs. So that those 8 number of outputs are in the form of 2 to the power 3. So n is equal to 3. So how many number of selection lines we need? We need 3 selection lines. So on the basis of those 3 selection lines, combination of those 3 selection lines, what we have to do? We need to prepare truth table for 1 cross 8 demultiplexer. So we will see how to prepare. Okay, so here we have 3 selection line 0 0 0 S2 S1 S0. These 3 selection line will be having 8 combinations. So it will for those 8 combination, one of the line output line will take the input. Okay, so suppose the input is D in or D, and the output lines are Y0, Y1, Y2, Y3, Y4, Y5, Y6 and Y7. So for these 8 output lines, we need to find out the Boolean expression. So for that, we don't have Boolean expression. For that, again, we have to prepare one truth table. So from the fundamental principle. So the here, the 8 combinations are here 0 0 0. So suppose that for this combination, D will go towards, D will appear at this Y0 line. Okay, and on the so at the time of when all 3 selection lines are 0 0 0, remaining line other than Y0 are 0. Okay, so this is the first. For the next combination 0 0 1, input will appear through that Y1 and remaining lines will be 0 0 0. Okay, for the next combination, input will appear across this Y2 and remaining line will be 0 0 0. For 0 1 1, it will appear across Y3 and remaining line other than this Y3 will be 0, and so on. For this last combination 1 1 1, this input will appear through this Y7. So we'll take this D here and remaining lines other than this Y7 is 0. So on the basis of this thing, we can find out the Boolean expression. So Boolean expression for Y0 will be what? Tell me. Anyone? Anyone? What will be the Boolean expression for Y0 and Y7? S2 dash, S1 dash, S0 dash, Y0. Okay. Y0 is equal to S0, S1, S2. Okay. Why are you writing this this S2 dash, S1 dash, S0 dash, Y0? How? What is the output? Tell me. Output lines are appearing. Okay. Yes. That's what I was asking you, whether you understand or not. Okay, so the thing is that, see, see, what we are trying to do here, the y0 to y7, we are, these are just the name of the output lines. Okay, output will appear across these lines depends on the selection line, depends on the combinations of the selection lines. Output will appear across these lines. Okay, so at a time output will go towards only at towards only one line. Okay, so for different combination, because here only three selection lines are here, we need to find out how many number of selection lines are there in that particular demultiplexer. So here we are talking about 1 to 8 demultiplexer. For that 1 to 8 demultiplexer, 8 number of output lines are there. So if we convert this, if we try to find out the selection line, so it is in the form of 2 to the power 3. Okay, so 2 to the power 3 is equal to 8. 8 number of output lines. So how many number of selection lines? Selection lines are 3, and input is D. Okay, D is the input. So we want that D input. We need to find out where that input will go. Okay, at what line it will appear. We need to find out. So these are just the names of the output. For that, these are unknown things. So to convert this unknown thing into known things, we need to find out the Boolean expression. So what is known here? D is known, and S0, S1, S2 is known. Okay, y0, y7 are unknown things. We need to find these unknown things in terms of the known variables. So known is D. We know that some data is coming. We know that as what will be the different various combinations of S0, S1, S2. We don't know y0 to y7. So we know we need to find out in terms of the known variables. Okay, so here we need to prepare the truth table. After preparing that truth table, we will try to find out the Boolean expression. So this Boolean expression for y0 will be what? In terms of the known things. Okay, so known are S2. So so y0 output here, we know that from the truth table that for this 0 0 0 combination, we here output is across y0. Okay, and other than this y0, other lines are 0. So we don't need to find out the expression for this. Okay, so for y0 it will be S2 dash S1 dash S0 D. Okay, so what this combination output will appear across this y0. Okay, next, for next combination we'll see. For the next combination, output the input will go across this, it will appear across this y1, and remaining line are 0. We know that, so we don't need to find out the Boolean expression for remaining line for this combination. So for this particular combination, we need to find out the expression for y1 only. So for the y1, it will be S2 dash S1 dash S0 and D, and so on. For Y2, what will be the combination? For Y2, it will be S2 dash S1 S0 dash D. Okay. Next, for 1 1 1, for the last combination, output will appear across Y7. So by this we can find out Y7. So Y7 will be S2, S1, S0, D. Okay, clear? Okay, everyone clear? Okay, so now we have the Boolean expressions for the various output lines. So now we can find out the implementation. Okay, we can implement according to the Boolean expressions. So here, this is the Boolean expression. This is the implementation. Okay, so for the implementation, if we observe y0 is what? See, y0 is s2 dash, s1 dash, s0 dash, and d. So y0 will be, this is s2 dash, s1 dash, s0 dash, it is and d. So these four lines will be the input of this first and gate. What will be the out y1? Y1 is s2 dash, s1 dash, s0 d. So here, see, this is s2 dash, this is s1 dash, and this is s0 and d. So here, this is y1. Next is, what is y2? s2 dash, s2 dash, s1, s0 dash. So y2 will be s2 dash, s1 and s0 dash. This is y2. And for y7, s1, this is, sorry, this is s2, this is s1, s0 and this is d. So all these four lines will be ended, which will generate sy7. So this is s2, s1, s0, d. Okay, I think it's clear now. Anyone? If you have any kind of confusion, please tell me. No? Clear to everyone? Okay, then we'll see. This is the demultiplexer. So we'll see how, because multiplexer is a combination circuitry. So we have different variations of the multiplexer. So we have 2 to 1 multiplexer, 4 to 1 multiplexer, 8 to 1 multiplexer, and so on, 16 to 1, 32 to 1, 64 to 1, and so on. Variations are there according to the number of input line and the selection lines. So there is a possibility that we can implement higher order multiplexer with the use of lower order multiplexer. So we'll see how to implement a higher order multiplexer with the use of lower order multiplexer. So what is the meaning of higher order? Which have high number of input lines, and lower order which has lower number of input lines. So okay, we have the order is decided by 2 to the power 2 to the power n. Okay, it is decided by 2 to the power n. So order, this is suppose n is equal to 2, so it will be 4 to 1. If n is equal to 1, it will be 2 to 1. So these are the variations. And if n is equal to 3, it will be 8 to 1 mux. So if somehow we have a task to implement some 4x1 marks or 8x1 marks, and we have only 2x1 marks available, and we do not have basic gates. So how we can implement? So in that case, we can implement 4x1 or 8x1 marks with the use of 2x1 marks. So first of all, we will try to find out the truth table. Okay. So for implementation 4x1 marks, we know the truth table. Okay, so if we talk about the 4x1 marks, and how many number of selection line, n is equal to 2. For those two selection lines, four number of combination, 0 0 0 1 1 0 1 1. Okay, so among those four input lines, only one will be selected, so according to the combination. So if, because we know that the mux is many to one selected is, okay, so output will be only one, depends on what is the combination of selection lines. Okay, so for 0 0 the output will be I0. For 0, suppose the inputs are I0, I1, I2, I3. Okay, for 0 1 I1, 1 0 I2, and 1 1 I3. This will be I3. Okay, for 1 1 I3. But how many number of marks we need? How many number of lower order marks we need? We need to decide that thing first. Okay, and how, by which way we have to arrange those number of lower order of multiple number of lower order of marks. So we need to follow certain rules. So for that thing, what we have to do? See, first rule is that try to find out how many number of lower order of marks we need. How we can find out this thing? It will be very difficult to find out. Then the rule is divide the the order of the higher order. We need to divide higher order with the lower order. So what is the task? We have to design, the higher order is 4x1 and lower order is 2x1. So here we have to divide 4 by 2. What is remaining? It's 2. We need to divide till the time we get 1. Again we need to divide 2. We get 1. Okay, so the total number of marks required is 2 plus 1. Okay, so 2 plus 1 are the number of 2 is 2 to 1 marks with for the implementation of 4 to 1 marks. Okay, understand how to decide the number of lower order marks for the implementation of higher order marks? We need to divide by the lower order marks. So higher order, if we want to implement 4 to 1 marks using 2 to 1, we will divide this lower order with the we will divide higher order with lower order. Okay, and we till the time we get 1 remaining. Okay, so 4 divided by 2 we get 2. Okay, then 2 divided by 2 we get 1. Now we'll stop. So we'll see, in the first phase we get 2, in the second phase we get 1. So how many number of marks we need? 3 number of marks. Okay, next, how many number of 2x1 marks we need to implement 8x1 marks? Tell me, we need to implement 8 cross 1 mux with the use of 2 cross 1 mux. Tell me how many number of mux we need. CS19B1027. Tell me how many mux we need to implement 8 to 1 mux. No idea? Anyone? 7. Okay. Good. So, how many number of 2 cross 1 mux we need for to implement 16 to 1 mux? Tell me. Yes. Okay. So now we know how many number of we have find out. Okay. So we know how to calculate the number of lower order mux need to implement the higher order mux. Okay. So now we know that for the higher order mux we require suppose this is a 4 cross 1, so we need 2 selection line, but for the 2 cross 1 we need 1 selection line. Okay, so suppose the selection lines are first you prepare the truth table. Okay, the selection lines are S0 and S1. Okay, so now how to implement? So for this particular case, for the first level of division we got 1, and for second level of division we got 1. So by following this order, in the first level we require two number of lower order mux, and the second level we require one number of mux. Okay, so here see, this is the first level, okay, and the next level. Okay, so now we know, and we know that the inputs of the two cross 1 mux are 2, so we'll give them the input, and we know that all the mux, any kind of any order of mux will produce only one output. So here this one, okay, this one. And one more thing is that it will have 2 cross 1 mux will have only one selection lines. Okay, so we'll give them selection lines. Now this will produce Y. So again what we have to do, the inputs are Y0, Y1, Y2, sorry, I0, I1, I2 and I3. Okay, so with same order we will provide them as an input to that those multiplexer. Okay, first level of lower order mux. So I0, this is I1, this is I2, I3. Everyone please put your roll number in the chat box. This is I2. Okay, this is I2. Okay, again the output is, suppose this is x0 x1, obviously this will not x0 x1, it will be this I0 or I1, or this will be I2 or I3. So output here go inside this next level of mux. Okay, now what about the selection line? The selection lines will be in the reverse order. Like the lower order selection line will go inside the first level of mux combination. Okay, so we'll give those line. So lower order, the LSB of the selection line is S0. So S0 will go here. Again S0 is will go here. So remaining selection line will go here. This in the second level of the mux. Okay, so now if we try to find out the truth table, suppose, so here for the this one, for this first, this is the first level, this is the second level. So in the first level of the mux here for mux 1 and here for the mux 2, if we try to find out what will be the value of x0, so here x0 will be for s0. Okay, for s0 0 and 1, or if s0 is 0 it will be i0, s0 is 1 it will be i1. Okay, and okay, next for this 2, x1 will be 0 1, it will be i2 i3. Okay, so next for the next level, what will happen, either i0 will be there or i1 will be there. So for s1, it will take two values 0 and 1. So x0 will be selected or x1 will be selected, x0 or x1 and I. Okay, so it will take two values i0 or i1 for 0 and 1. So if s0 is, suppose, if here if s1 is 0, okay, if s1 is 0, and it will s0 will take two values, okay, 0 or 1 for this. So it will generate either i0 or i1. Okay, for this x0. For x2, what will happen? It will, the lower for the first level of mux implementation, the lower mux will be selected when s1 is 1. So for s1 is 1 1 1, either i2 will be selected or i3 will be selected. It depends on s0. So it will be 0 or 1, or i2 will be selected or i3 will be selected. So this is the complete implementation of 4 cross 1 mux using 2 cross 1 mux. Any doubt? Clear? Anyone, any kind of doubt, please tell me. No doubt? Anurag Kumar 1006, tell me. No doubt. Okay. You know what is happening here? How to implement, how to design higher order mux using lower order mux? Okay. Okay, fine. So we'll see. Okay. So it's clear to everyone that how to design, how to implement higher order mux using lower order mux. We'll take one more example like 8 cross 1. So for 8 cross 1 mux, if we want to implement using 2 cross 1 mux, what we have to do, we need to divide. So this is 4 plus 2 plus 1. So in the first level of the mux, we need here 4 number of 2 cross 1. Okay, because 8 number of inputs are here. So we need 4 number of 2 cross 1 marks. In the second level, how many number of marks we need? 2 number of marks. In the third level, how many number of marks? We need 1. So this will generate the output. So suppose I0, I1, I2, I3, I4, I5, I6 and I7 are the inputs. So those inputs will be the inputs of the first level of marks. So I0, I1, I2, I3, I4, I5, I6 and I7. Okay. So again it will generate one output. So it will go inside this. And one more thing is that how to select the selection lines. So one selection lines will be there. So we'll start from the LSB to MSB. So suppose S2, S1, S0. First, the rule is try to find out the truth table and then see what is the order of the selection lines. So we suppose the order of the selection line S2, S1, S0. S0 is the low LSB, so it will go inside the first level of marks. So S0, S0, S0. Okay. Next, the next will go inside the second level of marks. So this will go inside S1, second level. This is S1. So and the MSB of those selection line will go inside this next level of marks. This is S2. So this is the implementation of 8 cross 1 marks using the 4 cross 1 marks. We'll see how to implement. Okay, tell me one thing. How many number of 4 cross 1 marks we need to implement 8 cross 1 marks? How many number of 8 cross 1 marks we require to implement 8 cross 1 marks? Tell me. Anyone? No idea? How many number of 4 cross 1 4 cross 1 marks we need to implement? 3 4 cross 1 for yes, we can implement. We can implement directly. But here, what is the rule? We have to divide by 2. Okay, 2. But the rule is that we have to divide till the time we get 1. Then what? Think about this. Okay, the next time I will ask you what if we the further division is not possible. Then what to do? Okay. So in the next lecture we'll see we'll design various kind of Boolean expression with the use of multiplexer. Okay.